Hello everyone, welcome back to SAT Math Question of the Day. Without any further ado, let's go to our question of the day. Please look at it, try it yourself, come back, and we'll hopefully offer different approaches on how to do it. Okay, note, figure is not drawn to scale, typical of a geometry problem. The figure above, line segment BA is congruent to DE. Tick marks are your friend. What is the value of theta? Aha, theta. That's a right angle. Interesting. Okay, so you have to bring in...
What is a right angle?
A right angle is an angle that's 90 degrees.
What? Wait a minute. You said what is a right angle?
Angle A. This angle here is a right angle. This angle here is a right angle because they have a tick mark there. So we'll make it even bigger.
Yes,
This is what's called an angle puzzle, and the way I approach it is I just start putting stuff in that I know, and I just plow right through it. It's sort of like crossing a stream where you go from rock to rock to rock. You just plow right through it and hope for the best. I mean, you know that this is 63, and this big thing is a right angle. Then this thing here is the complement of 63, which is what, 27? So you write it in. That's 27. Now, everything looks symmetric. So my gut feeling is that this would also be 27.
So this is 27. So the complement of that is this green angle.
Right.
Okay. And being the complement, it's 63.
That's 63, right. That's 63.
Now, we have two big congruent triangles.
Right. Yes.
Right?
Yes.
The BAE is congruent to DEA.
Right.
Which means that the labeled 63 degree angle and the angle of D are equal. So they're 63. So what we have is an isosceles triangle with 63 degrees on each of the equal angles.
Right. Yeah.
All of the angles add up to 180.
That's right.
Theta and its supplement also add up to 180.
Right.
Therefore, theta has to be the same angle that adds up to 180 when you add 63 and 63 to theta prime. So the answer is 63 plus 63, which is 126 degrees.
So that's you used what's known as the triangle exterior angle theorem. That if you have a triangle, this angle here is equal to the sum of angle 1 and angle 2.
Yeah.
So I took a chance and I said both of these are 27. If both of those are 27, then 27 plus 27.
Both of them are equal because the two triangles are congruent.
Right. 154 minus 180 is 126. Yeah, so you can get it that way also.
Yeah.
Now, Seth, you said the two triangles are congruent because of angle again. How did you say the two triangles are congruent?
Well, it's side angle side, with a right angle being the common angle.
Side.
The two equal sides are BA and DE.
Of course,
the vertical sides.
Of course they are.
The two equal horizontal sides are the coincident AEs.
Yeah, right. The reflexive property.
And the two corresponding equal angles are the two right angles.
Right.
BAE and DEA.
Right. So you did angle side.
Yeah.
There's the
Notice that the two triangles also Okay, yeah. So we don't know. We use the equality of the right angles to deduce that they are congruent. And then the congruence leads us to conclude that the angle D is the one that corresponds to the angle B, that the angle D is also 63 degrees.
Right, so you use side angle side. So
Yeah.
these are the two sides, the purple sides, the black angles, which are the right angles. Right. So you got purple, you got side, you got angle, and then you have the blue. Everyone loves reflection property, the blue side. So you got side angle side, side angle side. So that immediately tells you that that's that. But wait. Oh, right. Yes. I immediately knew. Wait a second. Wait. But you could do this a little more efficiently. You could do this a little bit more efficiently. First of all, my gut feeling when I got to 27 there was I immediately wrote 27 there. And that may be a faster way to approach it because you can see that both of those angles are 27. You do this triangle, this is 27. This is 27. Then you invoke that thing. If you have two equal angles, the sides opposite those angles are equal. Oh wait, we don't.
Oh no! Once you know those two little angles, once you know those two little angles are 27,
then you got it made.
Then you take the complement of. No, sorry, take the supplement of their sum.
Yeah, you take 27 plus 27. And then you subtract 180 off of that. Yeah. Yeah, so that's a faster way of doing it. So my gut feel turned out to be more efficient than Seth's approach. Yeah. So that's that. So it's 126. So let's see how they did it. Basically, you got to know when you're in the geometry area of congruence, similarity, and angle relationships, you got to know the theorems. You got to know the theorems of the basic theorems of geometry. In this one, we use the fact that the sum of the angles the right angle is 90 degrees. The sum of the angles in a triangle is 180. That's all you really need to know. And then with Seth did it through congruency, which is a more complicated way of doing it. Okay. So it doesn't hurt to know the ways to prove triangles are congruent, which if you want to go back, you can, we'll talk about it when we do our introductions, how to approach studying for the Math SAT. Okay, so let's annotate, clear all drawings, go like this and type 126. Okay, they have the unit of degrees on the theta thing. See, next to the theta has a little degree sign. Because they're asking you, what is the value of theta? You have to know what unit it is. Okay, so let's see how they did it. Oh, so now they're asking us for hints. So let's just hint through the problem, and then we can look at it sort of together. X this out. Okay, just hint through. Okay, hint through. Okay, here we go. So how did they do it? They did it. Let's add segment BD to make a rectangle. Oh, they did another way. We see that the two diagonals are equal. That's because rectangles have congruent diagonals. And bisect one another. Right, that's because it's a parallelogram. They don't say that. They don't explain why. So triangle ACE is isosceles. Yeah. Right. That's a more complicated way of doing it. Anyway, they are in the end. Wow. Now we see that it's 20. Then we see that angle on top. The angle near B is 27 because it's complementary. Okay, fine. Now, moreover, since A, B, and D are parallel because it's a parallelogram, because they made it into a rectangle, and rectangles are parallelograms, then you invoke the alternate interior angles. Boy, what a complicated way of doing it. There's always more than one way to do these proofs in geometry, these problems in geometry, these angle puzzles. We see that the angles, okay, once you know they're both 27, then you're home free. Wow. That's a sort of a complicated way of doing it, isn't it? Yeah. Plus you have to know how to draw, it's called an auxiliary line. Yeah. Technically, that's called an auxiliary line. Wow. Yeah, that's a complicated, completely unnecessary, right?
Right.
Yeah. Okay, well, the bottom line is there are multiple ways to do geometry problems. Some are easier.
Well, it's what you said. I like the way you described the approach. Fill in everything that you could figure out.
Exactly, and don't get so worried about how you're going to get the final answer. Just plug everything in that's the easiest and the most obvious to you, and hope for the best. This is different from some of the other problems where you start backwards. Like in a geometry proof, it's a good idea to start backwards and work both ways. In this situation, it's probably, my approach at least, is put down everything you can know as quickly as you can and hope for the best. Mm-hmm. And tick marks and labeling the angles help. So that's it for today. So now we have time to introduce ourselves.
I guess another thing to keep in mind approaching this is that the problem is to find the theta angle, the supplement of it called S. If you knew S, you could calculate the unknown.
That's right.
So we could try to find S.
Yeah.
To help solve the problem.
And S is also on the other side, right?
Yeah, S. And then similarly, the angle that would help you is on the other side.
Yeah.
These two are equal. No, because
yeah.
And then and then you could find S if you knew what this was. Right?
That's right. Yeah. Yeah, you can find S if you know what this angle is. This angle.
Yeah.
This angle. Yeah, which you can because you know that this, well, yeah.
Yeah.
Yeah. Okay. Yeah, how would you get that blue?
Well, what's really critical? Was really critical. Was critical.
This is 27 because of this. So that's
what was critical. Was critical is observing that these two, that the angles, various pairs of angles, especially this one, was it this angle that's marked 27 degrees is equal to the angle on the other side. It's marked 27 degrees.
Wait, hold on 1 second. It's not that easy to get the angle blue. It is not that easy to get the blue angle.
No, it isn't.
It isn't. It's a lot easier. So that's not a good approach.
Yeah, well, the problem is you get the blue angle. The critical angle. The critical thing to observe is that these two angles are equal.
Right, and you can actually calculate those two.
Yeah, they're two equal, and they're equal to the complement of 63.
Wait a second. I pulled something in and I didn't prove it. I said that this angle here is definitely 27 because you're given this is 63. Wait a second. I fooled myself. I said so casually that this is 27 because this is 63. Oops.
Yeah.
Oops. I just said that because it looked that way. And I didn't actually think it through. So I got the right answer.
Well, you may have heard me say that the two big triangles are congruent.
No, but I did it before. Remember I said before, I said my gut tells me that that's a 27, even though I didn't prove it.
Yeah. Yeah, what's disappointing about this SAT question? They say it's not drawn to scale.
But
it's close. It's so close. It's so close to scale that the problem is there anything in the diagram that's misleading?
No. You see,
and the answer is no. What they should have done is give a problem that looks like this.
I said I'm drawing it. This is Seth. Take your thing off. I did it. Seth, take your thing off. Seth, no.
I am doing it. This is not to scale. And then they say, is this a right angle? this is a right angle, right? Like that. They say this is equal to this. It's not to scale. Now figure it out.
Yeah, that's hard. No, Seth. That's cruel. That's cruel. You went overboard on that. You went overboard on that. If you're going to play around with anyone not to scale, just make one thing not to scale, like I did. See, go like this. Go like this. Make this a right angle. Make this a right angle, but make this, don't make this so high.
Okay? Oh, okay. Make it so that you would guess that the answer is 45. So that you would guess that the answer is 90.
No. If you wait, let me go back. If you did this, then you wouldn't have what I did so casually say that these two angles are equal.
Yeah.
Right? I wouldn't have casually said that angle 1 and angle 2 are equal if it was drawn that way. Right? But oh, by the way, we forgot the tick marks. We forgot the tick marks are critical, right? Okay?
Yeah.
I wouldn't have casually have said that. I would have had to think it through, and then you would have had to remember the reflexive property, and then you show the triangles are this triangle, right, and then this triangle are congruent because of side angle side. That's how they probably should have drawn it.
Well, another misleading way of doing it is. They should have given you the figure in which the whole thing fits into a square.
Okay.
Like that. This is not to scale.
Right.
They tell you that this is a right angle.
Right.
And this is a right angle.
Right.
And they tell you that this angle is 68 degrees.
Whatever, 63, 68, whatever.
Yeah, 63, 63, 68. That's not something arbitrary. This angle is 63.
Right.
That would lead you to incorrectly guess that the answer was 90.
Right, yeah. Right, in other words, you're saying that in this case it looks like the tick marks are like this.
Yeah. So there's this is actually this is a wrong tick mark. This is different from these two equal ones.
Yeah. I don't know. I think this would have been the better way of doing it, because this would have forced you to justify that angle 1 and angle 2 are equal, as opposed to what I said was it looked that way, which was completely wrong. Completely wrong. If you were in a real geometry class and you said, "Oh, this is 27 because it looks that way," and it's your gut feeling, like I did, wrong.
Gut feeling, my gut feeling.
Yeah, completely wrong. So I got the right answer, but I got it for the wrong reason.
All right, I think we beat this one. Finished.
Oh yeah, we definitely beat it together. Anyway, let's
introduce
ourselves. Yeah, so this is Seth Chaiken. He's Professor Emeritus, PhD Math from MIT, Professor Emeritus at SUNY Albany. Seth's brother Joel. I'm a PhD in Mechanical Engineering. And we are here to hopefully show you approaches on how to study for the Math SAT and how to approach doing the Math SAT problems. You can see we just did that. We just showed you different approaches on how to do a geometry problem. In terms of approaches for studying for the Math SAT, go to Khan Academy, Google it, Khan Academy SAT Practice, choose the digital and non-digital practice, whichever one you think you're going to take, and talk to your guidance counselor about which test you believe you are going to take. And then if you have any SAT math questions, please email us at satmathquestionoftheday@gmail.com, and we try to meet every day, Monday through Friday. We've been doing it for over a year now. So, that's it, right? We're done?
That's it.
That's it.
Goodbye.
Have a good day, everyone. Bye-bye.